because I'm not going to be sending out invites every time. Okay?
Make sure to like
I'm not going to email you the URL every time. Subscribe to my page. That way every time I access or post a video, you get a notice. So this is the last problem we got to, was finding the IQR for sodium. The regression equation, you can do it manually. Guys, there's a problem on the test where you're going to need to calculate B1 or B0 manually. What that means is they're going to give you the R, they're going to give you the standard deviation. Okay? They're not going to make you actually do the entire table to figure, but they're going to give you the needed information. So you're going to need to know how to do B1 and B0 manually. So know those formulas. And know those formulas. You can look back and find them. So to do number 23, the regression equation. So we go to our calculator, we go to our stats, edit a list, clear out our first two lists. It's wanting you to predict fat from sodium. So it's wanting you to predict fat. So fat's your Y variable. Sodium would then be your X. So we're going to put sodium in for our X1 column. I'm going to just run through this, typing these in.
I can't see your calculator screen.
I'm just typing in the data right now, but I'll rotate it for you can see it here in just a second. All right, so I've typed in this data. That's our X data. Our Y data is the milligrams of fat. Typing this in. Make sure you pay attention when you're typing it in, taking your time to not accidentally type it in wrong. I about did. Okay, so I've typed in the Y column. Going back to 22, finding the interquartile range for sodium. The way you can do this is you go over here to calculate one variable stats. Our sodium was list 1. And it gives you a bunch of data. If you scroll down, it gives you the 5-number summary. It gives you Q3 is 43, Q1 is 34. 43 minus 34 is 9. Okay? So you can use the calculator to get that information. But anyways, we can go also over here to test, go down or up, it doesn't matter, to linear regression t-test. Your X list is, well, I typed in as L1, so I need to fix this. My Y list was L2.
Like, how'd you get to that again? I'm sorry.
Stat, test, and then go up to linear regression t-test. And then we go down here to calculate. Now pay attention, it's giving you Y equals A plus BX. So A is your y-intercept and B is your slope. A is your y-intercept, B is your slope. And then here is your A and your B, 8, 16, and 11. And remember, it's Y equals A plus BX, or Y equals B0 plus B1X. The midterm is 1 close. The retake will not be.
Oh.
The retake will not be. So A is 816. B is 11.33. Y was fat. X was sodium. The answer is A. Now, going to 24, the best interpretation for coefficient of determination. You need to know coefficient of determination is known as R squared. When you do your linear regression t-test, it gives you R and R squared at the very bottom. Okay, you have to know, for one, it's R squared. Because if you notice, they have it as R squared and R as both possible answers. So R squared is 0.299. And it's always 29.9% of the variance in Y can be explained by the regression, the linear model, the equation of X. Okay, so Y is fat. 29.9% of the variance in fat is explained by small changes in sodium, which is X. So the answer is C. They're all very similar. Only one of them is interpreted correctly. Okay, you've got to make sure you understand that interpretation. The predicted grams of fat for a burger. So we've got the equation for fat being 816.14 plus 11.33 sodium. And it says, what's the predicted fat for a 25 milligram of sodium? So we just plug it in. 816.14 plus 11.33 times 25. We get 1,099.39. So the answer for that question would have been B. Number 26 is talking about the residual. The residual is the same as error in the prediction. So in order to understand how to interpret this, you've got to know the formula. It's error is equal to observed minus predicted. And the fact that the error of the residual is negative means that the observed had to be smaller than the predicted. The observed is less than the predicted, or the predicted is more than the observed. So, and that's in terms of the error, that's the error in the y values. These all have to do with y. So just talking about fat, right? The fat is the y value. So we can get rid of A and B because they're talking about the predicted and observed sodium. And then the observed is less than the predicted. The observed fat, which is the observed y, is 43.3 lower than the predicted. The answer is C. And then this prediction, the predicted fat is 43.3 lower than the observed. If that was the case, the residual would have been a positive number. That would not be. Here's our equation for reference again. The best interpretation for the slope. The slope's the 11.33, so that allows us to get rid of B and C. And the slope is always interpreted the same way. As sodium increases, as X increases by 1, the Y value increases or decreases according to the sign by however much the slope is. So as sodium increases 1, the predicted fat, this being positive, means it's an increase by 11.33. D is incorrect because this says as Y increases 1. The X, the predicted X. That's incorrect because we're trying to predict fat from sodium.